Welcome to our review on ionic compounds. So previously we've looked to see how ionic bonds are made, and anything that's joined by an ionic bond is known as an ionic compound. And two examples that you need to know about for your exam paper then are magnesium oxide and sodium chloride. So what we've got here then are just a table of key properties for sodium chloride and magnesium oxide that you really should try and remember for your exam. So the first thing you can see is that if we look at their melting points, they're both high. If we look to see if they dissolve in water, sodium chloride, which remember is just our normal table salt, will dissolve in water. Magnesium oxide, however, will not. We will find that neither of them conducts electricity when they're solid. However, if we melt them, so make them molten, then they will both conduct electricity. When we look and see how these positive and negative ions arrange themselves in one of these ionic compounds, they've got this very distinctive structure that you can see in the diagram there. We know that positive and positive will obviously repel each other, negative and negative will repel each other, whereas a positive and a negative will attract. So what we end up with is our negative ion in the very middle there is going to be surrounded by the positive ions because they're attracted to them, and then those positive ions will be attracted to other negative ions and so on. So what we end up with is this very large repeating structure, and that actually is something called a giant ionic lattice. The last thing you need to know about then is how to write these formulae. So what we've got to remember as our first rule is that the number of positive charges must equal the number of negative charges. So if we take the example of sodium and chlorine, for example, sodium has a single positive charge, so it's Na+, and chlorine has a single negative charge, it's Cl-. So because there's one positive and one negative charge, they just join together to make sodium chloride, which is NaCl. If, however, we had magnesium, then magnesium has two positive charges, and if we were still trying to join it with chlorine, which has one negative charge, we would end up with the formula MgCl2, because we'd need two chlorines to cancel out the two positive charges on our magnesium. So just remember to make sure that the number of positive charges is the same as the negative charges.